Good morning, friends. I hope everyone is doing well. I request everyone to watch my videos in a sequence for better understanding. In this video, we will discuss how to convert a hexadecimal number to an octal number. Okay. Now, hexadecimal, we can call it as a base 16 number, and octal number, we can even call it as a base 8 number. So, we want to convert a base 16 number to base 8 number. As I discussed earlier, we can do this process in two ways. What is the first way is that I can convert the hexadecimal number to a decimal number, and from the decimal number we can convert into an octal number. Already I have discussed how to convert a hexadecimal to decimal number. Okay, decimal number means base 10. Okay, from decimal number we already know how to convert into an octal number. So you can use that process. And the second way is we can convert a hexadecimal to a binary one. From binary we can convert into an octal number. Is it clear? So we can do it in the two ways, from converting a hexadecimal to decimal, from decimal to octal. And the second way is hexadecimal to binary number. Binary number means base 2 number to octal number we can do. So already I think everyone know how to you do the with the step 1, means the process 1. I want to discuss in the second way. Okay, how to do it is, from hexadecimal I will convert into a binary, from binary I will convert into an octal number. Okay, so now we will take an example. I will take that 1BC, which is a hexadecimal number. I want to convert into an octal number base 8. Okay, so how I will do? First I will convert into a binary number. Now 1BC, when you are converting into a binary number, each number you have to represent in terms of 4 bits. Let's take that C. C is what? When in hexadecimal, A is nothing but 10, B is 11, C is 12, D is 13, E is 14, F is 15. Am I right? Because hexadecimal numbers will have 0 to 9, and from 10 to 15 will be represented as A to F respectively. Now C can be represented as 12. So you should consider it as a 12. Now 12, if I want to convert into a binary number, how it will be? 2, I have to divide by 2 because I want to convert into a binary number. Okay, 2 6 are 12, I will get the remainder 0. 2 3s are 6, I will get the remainder 0. 2 1s are 2, and I will get the remainder as 1. So I got 1100 for 12. So 4 bits I need to represent. Okay, now C, B I want to represent. What is B? 11. 11 if I represent in a binary number, it will be 2 5s are 10, I will get the remainder as 1. 2 2s are 4, I will get the remainder 1. 2 1s are 2, I will get the remainder 0. Okay, so B can be represented as 1 0 1 1, and 1 I can represent as 0 0 0 1. If I represent in 4 bits, 1 I can represent as 0 0 0 1, and C will be as 1 1 0 0. So this is the 12 bits I got in the binary number when I am representing each bit in 4 bits. Now I need to convert this number to an octal. This is the final one I want. I want to convert into octal number. Now remember one thing. Base 8 is an octal number. 8 can be represented as 2 power 3. Because 16 I have represented as 2 power 4. So each number in a hexadecimal I have converted into binary with the 4 bits. That is important. Are you able to understand? See how I have represented 1100, because it is a hexadecimal. So hexadecimal number is base 16. 16 can be represented as 2 power 4. So each bit you have to represent with 4 bits. Now take it. It is an octal number which is base 8, can be represented as 2 power 3. So meaning is that from this binary number you take 3 bits, separate it with 3 bits. This is 0. Okay, are you able to understand? So now if you say take this as a binary number, you convert into a decimal number. What you will get? 100 is nothing but 2 power 0, 2 power 1, 2 power 2. So you will get 4. Are you able to understand? 1 into 2 power 2 plus 0 into 2 power 1 plus 0 into 2 power 0, because the weight of this one is 2 power 0, 2 power 1, 2 power 2. And this is 7. How I got it? 1 into 2 power 0 plus 1 into 2 power 1 plus 1 into 2 power 2, which is equal to 1 plus 2 plus 4. So you will get 7. Okay. Now similarly, if you take this one, this is how much? 110, which is equivalent to 6. If you want to verify, you can verify. 0 into 2 power 0 plus 1 into 2 power 1 plus 1 into 2 power 2. So you will get 0 plus 2 plus 4, which is equivalent to 6. This is 0 only. So it is equivalent to 674 base 8. Okay, 674 base 8. Then you can ask me, sir, why you did not add 0? Please remember one thing. If I say 0, 5 or 5 both are same only. If I say 50 and 5 both are different, so I can remove this 0 front, so that's why I have removed. If I remove 0 from here, it is a problem. Are you able to understand? Now we will discuss another example for better understanding. Okay. Now let me take another example so that you can understand the concept in a better way. Now let's take that 65A hexadecimal I want to convert into an octal number. So what I will do, I have a is 10. So 10, if I divide by base 2, I will get 2 5s are 10, 0, 2 2s are 4, I will get remainder 1, 2 1s are 2, I will get the remainder 0. So A can be represented in 4 bits as 1010. A is nothing but 10. Okay, 1010. Next you have 5. 5, how you will represent? If you see that it is, okay, 5 if you want to represent, those who does not know how to binary convert, I can do it for you. So 2 2s are 4, okay, you will get the remainder 1. 2 1s are 2, you will get the remainder 0. So it is 101. Now I have represented in 3 bits, but I need to represent in 4 bits. So you need to add another 0. Is it clear? If you write it as 0101 or 0101, both are same one. If you want have a doubt, you can check it. This is 1 into 2 power 0 plus 0 into 2 power 1 plus 1 into 2 power 2 plus 0 into 2 power 3. This is not creating any impact because it is 0 into 2 power 3. If you see it, 1 into 2 power 0 is 1, 0 into 2 power 2 is 0, plus 1 into 2 power 2 is 4. So you will get 5 only. Okay. Now you need to write the 6. 6 I can write it as 110 and a 0 I will add. So this is the way I have converted a hexadecimal to a binary number with 4 bits allocated for each number. Now I need to convert into an octal number. So how many bits I need to take at a time? 3 bits. So these 3 bits I will separate, these 3 bits I will separate, and these 3 bits I will separate, these 3 bits I will separate. Now if you see that I got 010, which is nothing but in a 2 in decimal number. 011 is nothing but 3 and 001 is 1. 011 is equal to 3. So 3132 is in the octal number, which is equivalent to 658 base 16. Okay, so I hope you have understood how I converted this 65A to a binary number with 4 bits assigned. Then from this binary number, how I converted into an octal number. If you still have any doubts, feel free to ask me. I will clear your doubts in the comment section as early as possible. Hope you have understood everything. Thank you so much for watching my video. Have a nice day.